So Mark, thanks so much for giving me the opportunity to talk with everybody there today. And at first we were talking, I mean, it is the iCollege, so, teleconferencing, why not? So we decided to do this method so it's a little more engaging, a little more personal, makes it a little less likely to kind of miss the stream. But this is a really, really interesting subject matter. I got the syllabus from Mark. We had a chance to talk and teed up a couple things that were, I think, relevant to what you all are doing. And the intent here is to go about half and half. Quick run through some slides. It's really one of these 30,000 foot level kind of things. And then there's plenty of time for, I have some optional discussion topics based on what I was talking to Mark and some things that might be interesting to you all. Before I even begin, before I even start, I have to say this. It's all about the question. I understand that predominantly, I would imagine everybody predominantly in there is in the enterprise architecture field. I used to work with a small software development company, and we had an enterprise architect division. Smart work that goes on there. And I know a couple people who, in our old company, that were involved with, like, say, process modeling. Modeling is fun. Modeling is where the rubber hits the road, and that's where a lot of time is spent. In fact, a great deal of time is spent, mostly with cleaning up data. But no model, regardless how good it is really any good unless it provides a solid answer to a decision maker on a question that they had. I like to tell people, you can give me a pile of data and I'll tell you something about it. I don't know if it's relevant, though, to what you want. So in terms of, if you want to think about it in terms of requirements generation, the ability to get with a decision maker, and you can't just walk in and say, what do you want from me, or what would you like me to answer? You're going to have to work with people. I find this in my current project. I had no expertise in that domain space. It's a ballistic missile defense project. But I have now established a relationship with those subject matter experts, and this is going to come up a few times in our talk this morning, and that has made all the difference in the world. They are actually involved in the analytic process now. They've taken on ownership, and to make a point, one of the ballistic missile SMEs is on a conference paper with me that we're going to present later this month because he helped in the process modeling. So it's more than just a nice idea. It can really transform your projects that are analytic in nature from you just guessing to really having a collaboration. So I can't say this more or often enough, but you really have to go all the way to the question. And it takes a lot of time. It takes a lot of time. Okay, big data, analytics. We'll drive on down to a couple of key topics that come from this, but this is the foundation of it. Not going to dally here. Probably things that most of everybody in the room knows. On the left-hand side is big data. It's a, yes? Oh, yeah. Oh, wait a minute. Don't hit the video yet. Okay. I guess I see that I forgot to put back. So there was my slide that said it's all about the questions, the model, and the answer. You didn't miss much. So we're right here. You can see my slides now, correct? Okay, my bad. Okay, big data. Terrible term, right? Terrible term, but you know what? It's the thing that gets executives intrigued, and it is the thing that is driving the force, just like the cloud was 10, 15 years ago, and just like the web was in the early 90s. The executives want a piece of this thing, and you're going to see in this video that comes up that all companies are data companies, and it's a great little use case. So big data, there's a quote there from a guy named Francis Diebold, and by the way, I've already put these up on a website, and I will show you that link at the end. So don't worry about taking profuse notes. We're going to give you these slides. But the person who really was first quoted with the term was this Laney in 2001, and he was this chief scientist for Sun Microsystems. And there were the 3 V's of big data. Then it used to be a real big consideration about volume, so much data, terabytes coming off of sensors. the velocity, how fast it was coming in, and the variety. And now the volume is not the big issue. It's kind of funny. Big data, it's not about big data. It's about fast and different data. And that's the thing from an enterprise architecture standpoint that's going to be most interesting when you start looking at the various analytics, online, right off the wire type systems. So the term will still be out there. It's ill-defined, but it gets you in the door. It gets you in the door with senior leaders. On the other side is analytics. And analytics is not one dimension. It's highly dimensional. You can't just throw a bunch of PhDs in the room. This is the common thought. We'll hire the data scientists. They're the unicorns, they're called. You won't be able to find one person that can do all of this, except on rare occasion. And when you can, you hire them right away. But it's really a combination of business intelligence, math and statistics, machine learning, which is really the domain of computer scientists these days, visualization techniques to communicate things, and then having your domain experts in the room. This is having a big impact. This is a slide I put together that I found out is actually mirrored in a book called The Fourth Discipline by IBM that I just found this past week. It's an old book. But there's Galileo up in the top left. Everything he knew is the things that he could see with his own eye. It was empirical. Isaac Newton, apple falls, what's causing that? We move out of the Renaissance and the Enlightenment and we move into the 30s and the 50s and we start getting into the realm of theoretical, math-based statistics because we have very, very small sample sizes and everything was theoretical. Every statistics course that probably everybody in the room, including myself, has had is a theoretical statistics course. Unless we have an expert on Bayesian statistics, everybody knows theoretical statistics. As we enter the 60s and 70s and now through the 00s, we've got computational everything. Computational finance, computational fluid dynamics, computational statistics. So the size and the amount and the availability of data, open data from the government, is changing things to where now I call it, it's almost like we're going back to the beginning. And I call it empirical plus plus. Where now you can literally grab a bunch of data from census, merge it up with stuff from information that you might have or weather stations, and you can base your analysis not only on what you see, but using the tools from the past. So we don't digress, but our going forward is starting to look a little similar to where we've been. This, I'm going to read the little card. This comes out of a nice book because it captures the quote that has called data analytics the sexiest career field of the decade. And that in a 2011 McKinsey report, McKinsey & Company, very big consulting firm, they had said, and this is a quote off the card, that by 2018, and I think this is now accelerated, there would be a shortage of 140 to 190,000 people who, and this is the key words, have deep analytical skills, as well as 1.5 million managers and analysts that have the know-how to use the analysis of big data to make effective decisions. And I like here what Fawcett and Provost say, because they quip, and you can see this maybe when you get the slides, it says, why 10 times as many managers and analysts than those with deep analytical skills? Surely data scientists aren't so difficult to manage, that they need 10 managers. And I like this quote because it points to two things. There really are few of the deep analytical thinkers. These are the people creating, developing algorithms to do voice recognition, optics, like the Google car. But on a 10-to-1 ratio, this report said that there needs to be people who then can converse with them, and more importantly, are going to be the managers between those people and the people in the C-suite on a commercial space or in senior leadership ranks in government spaces. Somebody who can make that connection between the deep analytical thinkers and what they do. And a lot of them now, that gap is being filled also with grad school. A lot of master's degree programs in analytics, and they're going to come out fresh with a lot of great math and comp sci techniques, but they won't have an understanding of the business domain. And that's where these 1.5 million managers, and that's you all in the room, are going to come in and play in. So here's the team. You know, we used to have something called the webmaster. Anybody remember those people? They did everything front end, back end, security, passwords, content. They were it. Now, if you were to go to the Bureau of Labor Statistics, I do this in keynote speeches, is you'll find that that term has been redacted, and it's called web development. You all know it's a team sport. It's the same with analytics. So what I show you here is the five spaces of analytics that you saw earlier. Business intelligence, machine learning, which is really heavy comp sci development, statistics, visualization, and a domain, and I put a slash in there and said analyst. Because really everybody who can think is an analyst. You got political analysts on TV. An analyst isn't limited to numbers. But if you notice, there's a little tag I've put as to what each of those types of skills is lacking or where a connection needs to take place. Your machine learners are out there hacking away and can come up with predictive models that are 0.99% or 99% accurate, but they can't explain them. They don't understand what's going on statistically. Meanwhile, your poor statisticians don't know how to work at large scale. When I work on my box, everything has to fit inside a RAM. And that's not going to last much longer. I need to be into the Azure cloud. I need to be on AWS. I need to be pulling live streaming analytics off of a Hadoop or a Spark kind of a cluster. The visualization people, the artists, they need to get more into coding, like JavaScript D3 as just one of many examples, to really bring their art to life. And then the business intelligence people need to think a little more algorithmically because they're used to static displays. Once they've built a dashboard, it's good, it's done, it's over. But where are the algorithms that now start turning things on and off in a dynamic way? And that's happening. That's happening just with the Power Query, Power BI series that Microsoft has put forward. Then we got the domain analysts down at the bottom there. And the reason I put plus data products is you should be asking not for white paper reports, but data products. Products that are web-based, products that are interactive, products that you can use that allow you to continue the exploration after the contractor's gone away, after your team has gone away, and working on another one. Now, for you all, I actually used this product before I joined Booz Allen Hamilton. This product was one of the reasons why this is one of the products that now we're getting a feedback. That's okay. So we're, this resource here, Field Guided Data Science, and you see the link, is a wonderful free document. And I, again, was using that before I joined the firm. And it does a wonderful job explaining at executive level, one page on data science, a single page. Next, you get into about 20 pages and it explains what's going on for managers. And then even for practitioners, it's got a wonderful, the bulk of the document is about techniques. What models work? When should they be used? When shouldn't they be used? It sort of gives a logic tree flow. Also good for managers who are working with a team of developers who know the difference between a k-nearest neighbors versus a k-means cluster versus a support vector machine algorithm. And if you don't, someone could take you upriver, right? Because you don't know the limitations of those. And why would you do an SVM for material that's spherical in nature, like geographically spaced stuff? If these are terms that are new, this book, free online, highly recommended. Okay, here's the meat. This is the framework that I've been developing on, and I've been tying together three big things out there. And in the middle, I say it's the up, down, and all around. You see our computer scientist and our statistician in the middle. We need to be in alliance with one another. Computer science has become to dominate the field of data science. They could, if people aren't careful, lose track of what's been happening statistically and mathematically and fail to be able to explain their results. But the statisticians aren't going to be able to do it because they walked away. At a London Society of Statisticians, they decided that they'll come crawling back to us, was the essence of the quote in this published report. I think that was a mistake, an unfortunate one at that. Now, we all have relationships. Up from us is our domain, and that is becoming the Internet of Things. Hey, Mark, I'm going to put you on mute. just so. So if you need to get a hold of me, maybe you can hit me with a chat, but while I'm getting through the guts here, the reverb just kicked in, and I don't know why. So we've got the Internet of Things. That is really the domain space that you saw in the earlier slides. We're going to look at that in a few slides in detail. And then you got the data lake. It's a controversial term. Some people don't like it. It really, some will say it's as BS as the term big data. But again, it's got some stickiness to it. And it's not a way of changing things, but a way of really starting to do things for the modern age of data and what we've got to deal with. So here's a quick highlight. Now, this report came out just 2 days ago. You'll see it down there at the bottom. It was an article on TechCrunch, and the report itself was by Spark Labs, and it was their industry overview for 2016 of the Internet of Things. I understand there's a Chad in the audience who had an interest in this topic area, and I just wanted to say this is where it's at. This is where it's at, and I wanted to share the 5 key areas that they found. You're probably familiar with some of these. Down in the bottom left, the connected home, the Nest thermostat, the ADT security systems. This is the Internet of Things is a array of sensors that come through our machinery, even our LG refrigerators. These are things that will tell you that your eggs are low, that somebody has knocked on your door, etc., etc. There's even products for pets that are machine learning based that will dispense food based on patterns that they see walking around. Wearables like Fitbit, they're not the cutting edge and they're not changing the world, but they are a beginning. Healthcare, telemedicine, the ability to monitor a patient constantly. This can reduce a hospital, what would be the word, admission, which costs about $1,800, they say in the trend report. So Internet of Things in the healthcare space. Transportation, or as otherwise talked, industrial. Tons of industrial topics. In fact, it's so big that in their report, they don't discuss it because they think it's worth its own report. So that's an area to watch. And then you got your robotics and drones, whether it's in manufacturing or the future of drones, which is still a wide open. One of their key points is that we're in the early days of the learning curve here. I would suggest that anybody in the room who's involved with enterprise architecture is start plugging into the press about the Internet of Things. This is where it's at. It's not going away. So now I wanted to show you the future of that, because the Internet of Things is already here. It's not the future. It's just going to get better. But there's very interesting use of biologics. I heard a guy named Matt Crespi, who was a RAND think tank person about 4 years ago now, who said, what are our best air quality sensors? I drove past an air quality monitor on the way here yesterday. The best air quality sensors that we have are our trees. And the day that we can connect those to the internet, you can just imagine the size of the sensor array that we have there. But let's take something that's really happening now. Mark, if you'd run this YouTube video.
I'm here to share a story with you about the connected cow. Yes, there is such a thing as a connected cow. It's a sexy story. It's got all of the buzzwords of today, the Internet of Things, the cloud, data science, analytics. But it's also about how a little bit of ingenuity can transform even some of the oldest industries in the world. And let me explain what that means. That's a connected cow that I'm talking about. Look at those pedometers on their feet. I'm wearing one of them. It's made by Fujitsu. It's very reliable. It has a 5-year battery. It can survive even the toughest environments in the farm. And it's constantly measuring the number of steps the cow takes. And that data is being sent to the cloud, into Microsoft Azure, where there is a service that's analyzing the number of steps the cow is taking. So, do cows need to take 10,000 steps a day too? Before I give you the answer, let's take a step back. Every company is a data company, even the ones you least expect, even dairy farms. Now, dairy farms have all the constraints of a modern business. They have a fixed production capacity. They have a herd that they have to manage. There's farm labor, which is very expensive. So what could a dairy farmer do? Well, there are two important controls. First, he can monitor for disease and prevent the loss of herd by early detection. Second, he can improve cattle production by accurate detection of estrus. Now, if you remember high school biology, estrus is when the animal goes into heat. And it turns out that cattle goes into heat only for very short durations of time. That's true about all farm animals, by the way. All animals, they are ready to mate and have children only during very short windows. Well, so there is an incredible leverage point here, and let me explain that with a chart from a scientific paper. These days, with artificial insemination, the conception rate is pretty high, 70%, which is very good. But the methods for estrus detection are age-old. For millennia, it has been the same observation. And even under best observation, you get about 55% accurate detection of estrus. When you multiply the two probabilities together, you get about 39% consumption rate. But if you could use technology, if you could move that detection to 95%, well, then look at the improvement you get. 67% conception rate, up to a 70% improvement potentially in cattle production. That's very material to the farmer. But this turns out to be a harder problem than you think.
Okay, so a little fun and a ton of articles out there on this topic. Let me continue the story. So, you've got a cow wearing a pedometer. Look at the architecture that's involved here. It's got a 300-foot radius. It shoots up to this antenna to a router, which transmits and sends its stuff into the cloud, which is doing online analytics with Microsoft Azure. Data scientists have looked at this stuff. They have looked at lots of different ways to determine when estrus is in, the cow is in estrus. They've looked at the waste products. They've looked at the blood, the weight, the temperature. They are fortunate in that a pedometer was a simple gauge. And when the online analytics working overnight, and what's in one of the articles out there is it says this type activity typically happens between 10 p.m. and 8 a.m., right when that poor farmer is exhausted. But when this happens in the analytics, just like a fraud detection system determines that's when the cow is in estrus, the farmer gets a notification on their text, on their phone. The aqua line is a non-conceiving cow or a cow that is not ready for artificial insemination. The yellow line shows you the day-over-day pattern that has been proven to be 95% effective. And then one of the things he talks later, if you watch the full video, is that depending on when they do the artificial insemination, if it's at the front half of that window, they get more than likely a female, if you need dairy cows, or at the back end of that, you get a bull, if you're more into that field. So what Siraj called this was AI for AI. I thought that was pretty cute. But data scientists are the users here. And that's going to be a point when we talk about data lakes next. So data lakes are adding, not replacing. You have operational efficiencies with data warehousing that's been going on. But now you have lots more data hitting that warehouse. And the controversial part about this is whether you keep all the data or if you're selective in what you store. Here is an article graphic from the source shown there, cheat sheet, what data executives need to know, comparing a data warehouse to a data lake. I'm sure many of you are familiar with these type topics. Schema on read versus on write. You're not going to have a nice SQL database. There's a lot more use of graph databases now out there, which is just relationships. We have a node and an edge. Document databases are also very popular. So they're not, and everything hasn't gone relational database, and it won't into the future. The bottom there, your business professionals have been your data warehouse users. Serve up a query from SQL. What you've got now in the data lake is the opportunity for data scientists to dip in and go ahead and grab stuff that they can use to make business impactful decisions. And you saw some of the numbers in the previous video. I know you're doing SWOT analysis, and that same cheat sheet provides this SWOT analysis. And you can see that on the strength side, there's the lower costs that we're starting to experience now with these clusters versus standing up servers. It really can become a one-stop data shopping experience when you're allowed to bring in all the various unstructured type data into one source without having to put it in separate stores. And the opportunity for this is the advanced analytics that can be performed with it. You're not just limited to what you collect. You're also able to bring in collateral information like environmental conditions or things that aren't otherwise structured. On the downside is it is a bigger data management, and this is where the enterprise architects are working at it. Your comp sci guys are working at it to, Hadoop, in terms of skills, it's become much, much easier. But just as it becomes easier, you got Hive, Pig, Spark, you have all these HDFS type systems that are coming up and online, and you need skilled people to use those, and there's a certification process for that now. That is the presentation to sort of give you the idea of analytics and enterprise architecture, something that we call enterprise analytics. At this point, I wanted to leave the last 15 minutes for either questions, or these topics are ones that I saw in the syllabus and I thought might be very interesting to discuss. I have a few slides on each of these because when it comes to scales and measurement and the nominal scale that Mark's been teaching, I cannot tell you how often that is abused and misused, and it can cause problems as simple as with a survey. Similarly, there's a few rubrics there like San Francisco, California that you can remember if you want to get into the cleaning and exploring of data. So these are more analytical topics here. So Mark, I wanted to open it up now to either way. Questions about the presentation, any of these discussion topics, I'm here to support any of that. Those are easy. I can do both. These are all quick topics. Notice the date. This report, which appeared in the journal Science, no slouch of an article, appeared just 60 years ago. And up until this time, the people who were in this space did not have a standard way to think about scales and measurement. And I took them for granted until a mentor of mine shared this paper, which is available at that source, and it's an interesting read. But the highlight, the nugget that comes from it is the table 1 here. And let's start at the bottom. Ratios, we know that that's just two numbers combined together. Got it. Intervals. That's when you get into those continuous variables. And when you start working in analytics, you have to be very aware of data types. No different than if you've worked in, say, SQL and you have to assign a data element to a data type. Is it a time format? Is it a float? Is it an integer? Well, the two big ones when it comes to statistics and analytics is going to be categorical versus continuous variables. They have completely different approaches. If you're doing something as simple as a hypothesis test, everything changes just by being able to identify a categorical from a continuous. And to that point, when you have a data science team with you, depending on if they're more what we call affectionately the code monkeys, which from the developer guys, they call them script kiddies. You can get people who just know how to code up things, but they really don't appreciate the stuff that they're touching. And this is where they're going to need some guidance and leadership. And you can provide that even by asking a simple question about what kind of data types do you have, then called scales of measurement. So interval is something where you can take all the statistics that we love to take. Give me the mean. Give me the standard deviation. And then there's a couple other more statistical ones there about correlation. Now, if you don't have continuous variables, the game changes a little bit. You have two types of categorical variables out there. One is an ordinal, which, as it says on the chart, determination of greater or less. A senior is greater than a junior, is greater than a sophomore, is greater than a freshman. High is typically greater than medium, which is typically greater than low. Now you don't have an interval between those. I don't know how much greater medium is from low, and I don't know how much greater high is from medium. And you shouldn't try to think that way. So this is when you're left with medians and percentiles. This is where it impacts your survey development and your reporting. I can't tell you how often, if not every week, I see people in my profession taking the average of a 1 to 5 point Likert scale survey, and it's just not, it's meaningless. Because people don't know that the 2 is twice as great as 1 and 4 is twice as great as 2. All we know is 1 is greater than the other. Now, I presented this and people say that the numbers come up nearly the same, and that is true, but the statistics that are applied to a median and the types of testing for hypothesis and confidence intervals are greatly different for a median than a mean. So that's sort of a foot stomper for you, because you will have someone come in and present a set of slides that shows you the averages of the responses, and now you've got something to inquire of them if you wish to. The nominal is where there is no, it's like spring, summer, fall, winter, and that's probably got ordinal. Men, women, chocolate, vanilla. One is not greater than the other, although we all know great chocolate is better, but there is nothing greater than the other, so all you're left with is pure counts. You can't take an average of chocolate, but you can find what's the most frequent. And a lot of statistics that are going on in analytics space in the work I do is just simply aggregating large sets of data, taking counts, and finding what's the most frequent. In some ways, the statistics are simple. It's the gathering and getting the data together, which, let me show you this slide. If you personally are going to get involved with a data set, whether it fits on your Excel 1 million plus lines, if it's 50 lines, or whether you're about to embark with a team onto a 0.5 terabyte of data, there is structure with cleaning and exploring data. And the CEO of Kaggle, which is a great competition space, has said in a quote that I have of his, 80% of the time you spend doing analytics is cleaning the data. The other 20% of the time is complaining about cleaning the data. It really consumes. There's another informal survey from the University of Washington where he talks to postdoc students, and they spend up to 90% on average of their time cleaning data, and the other 10% applying their postdoc mojo to the National Science Foundation grant that they're working on. So being able to read about and clean data, it's not trivial, but there is a structured way to go about it. And when I teach it, I try to remind people that the birthplace of big data and all, and the big cool stuff happening is San Francisco, California. And that means you summarize the data by using a tool that can give you very quickly, you get a chance to see all the percentiles, the modes, the medians. It instantly lets you know whether you've got categorical or continuous data. You can sense skew and kurtosis right from those numbers without even having a number for skew or kurtosis. Because if the median and the mode, the median and the mean are far apart from each other, you have a skewed data set. And that you can apply certain statistical techniques to. Then you go into non-parametric techniques. And those are very powerful, and they're much easier than statistics, and they're underused out there. Once you've summarized the data, you can decide what do you need to fix. There are nice books out there on the open source on imputing data, I-M-P-U-T-I-N-G. You have to choose whether you throw an observation out, which you may be losing valuable data, or if you keep it, there are methods to fill in blanks. This is not a field of itself, but it's an important area that if you are going to start tackling an analytics project, be very cautious of how you choose to impute, but please don't simply just throw everything out because you have missing cases. It's a strategic choice that you have to make analytically. Once you've summarized and you've fixed, you have to go back to the topic we just talked about and convert any variables that you need, maybe from a character string into a factor or an ordered factor, to allow the tool that you're working on, whether it's in the cloud type analytic system or whether you're using R or Python on your own machine, they treat each variable as a data type. And you're going to want to convert them. And it's not a difficult process, but it's a sit back, get a cup of coffee, and think about the data types that you want in your analysis because of the modeling that you're going to do. And then adaptation. This is when you, very, very common with time, date stamps, adapting what you have to what you need. And that's when it gets a little softer. But if you remember San Francisco, California, you've got the whole class on cleaning data. And this is 80% of what us analytics types people do. Once you have it cleaned and ready to go, you can explore it. And the 4 steps of that, again, there is structure, because I talk to people and they think, well, exploring data, you're just out there in the Wild West and you have no real guidance. Not true. We talked about having a good question. That should drive the entire study. Well, when you embark on exploratory data analysis, you should have some good questions that you can focus in on. And what you do is you look at the data. And I've got a nice example here of a very famous, you can look this up on Wiki. I generated this in a stats package that I use. But the Ansom's quartet was built specifically to show that the set of numbers you see there, 4 data sets, if you do the summary statistics, they all have the same mean, they all have the same standard deviation, they even have the same linear regression line that you see plotted there with the same R squared and adjusted R squared. If you just stayed with tabular output, you would be fair to think that you've got identical data. But when they're plotted, you can see they're very, very different. And each of those have different problems when it comes to influence points, leverage points, or nonlinearity that you can't just apply a linear regression to, which you get even that choice is in a package as low as Excel. So you have to look at it visually. So your visualization skills are useful. It's worth finding some tool that you're comfortable with so you can look at data quickly. Then you want to look for relationships on site. Look at scatter plots, as you see here, and you can see in that top left X1, Y1 that there appears to be some kind of relationship. They all appear to have some kind of relationship, but you're going to most likely see something like that. And that one is also highly correlated, which is the next point. You will get, it is worth your understanding, and you can get this out of an Excel matrix, what are my correlations, and it's a pairwise measurement between every 2 variables. And even if you have 500 variables or features in your set, you can get the correlation between every 2 of those, and it spits out into something you can look on your screen in just a couple of slides of your mouse. You're looking for then things that are strongly correlated. That correlation will go from -1 to 1, minus being negatively correlated, positive being positively correlated. That plot to the top left is positively correlated, and I would say that's pretty strong. That's probably a 0.7. But then you have to do a test, because depending on the number of data points you have, you got to find out if it's significant or not, whether you can rely on that relationship and bring it into your modeling phase, because that is where the real work happens. All the stuff you saw with the cows happened in the modeling phase. I like this example of correlations. As you can see, the number of civil engineering doctorates awarded, which is information from the National Science Foundation, when that's mashed up with USDA's information on the consumption of mozzarella cheese, shows that they're clearly correlated, don't they? That website by Vigen is a fun place to visit. It has dozens and dozens and dozens, and he even invites you to go out and find a spurious correlation and add it to his set. It's sort of a community project, but it's a lot of fun, and you would all agree that that correlation, you can find it in the data, but is it significant? Likely not. Mark, that probably puts it at time. I can take questions, but I wanted to point out that this website here, it's just a running blog space, and I have the slides posted on a link. So you can pull these down and you can have them. And if you have any questions for me, you can reach out to me on LinkedIn or on Twitter, and I'd love to be able to engage with people on a more personal level.